Great. So hello everyone to this month's Armchair Travel event. I'm delighted to welcome you all on this beautiful sunny evening here in Cambridge. It's great to see so many of you coming back to enjoy these events and to see the new faces in the crowd too. I very much hope you enjoyed this evening's talk. This event is hosted by Indus Experiences, who run a number of our tours to Asia and Europe. I'm delighted to also introduce and welcome this evening's speaker, Professor Mike Searle from the University of Oxford. Oops, slight slip there. Just to remind you all the Armchair Travel events are recorded and including this evening's event. And if you have missed any of the events we've previously held, these can be found on both the Oxford and Cambridge Alumni websites. I would now like to hand over to Asia from Indus Experiences.
Thank you, Claire. Thank you, everybody, for joining us once more. We've been running these the armchair talks for just over a year or so, and really glad to see that they are still very popular despite everything improving now. So just very quickly, wanted to give a little information on this geology tour to Oman, which we are hoping to operate in January 2023. The tour leaders for this tour are Mike Searle and Professor Mike Searle and Professor Levell. The itinerary and the fully detailed itinerary is available on the website. I'll put a link in the chat box so you can go ahead and have a quick look. Any questions, any queries that you have, please do contact us. Again, the contact details I will pop in the little chat box there for you to grab. And without further ado, I'm going to hand over to Mike Searle now. I don't think he needs an introduction from me. So Mike, over to you.
Okay, thank you very much, Asia, and thank you, Claire, as well. It's very nice. I hope somebody's out there. I'm not just talking to myself, but anyway, it's nice to see you all. I'm going to talk today about the geology of the Oman Mountains, and it's related really to this tour that we're running for the Oxford Cambridge Alumni in January 2023, winter after next. And this is in combination myself and Bruce Levell from Oxford. So we have both been working in Oman for a very long time. Bruce was in the oil industry in Shell and PDO, Petroleum Development Oman. I've been in Oxford for 30-something years and having research projects in Oman pretty much every year. Okay, so this picture at the front is an aerial picture looking over the Oman ophiolite, which is by far and away the world's biggest, best exposed and best studied ophiolite anywhere in the world. An ophiolite is a slice of oceanic crust and upper mantle emplaced onto a continent. So you can't see the geology in the oceans, you have to rely on geophysics to have a look at them. But in Oman, we have a section about 15-20 kilometers thick through the upper mantle and the lower crust. And this has been placed onto the continental margin of Oman. You can see the mountains in the background here at Jebel Nakhl and Jebel Akhdar. These are the shelf carbonates, Permian and Mesozoic shelf carbonates, which are spectacularly well exposed all through major windows in the Oman mountains. So Oman is in Eastern Arabia. It's this little Eastern Peninsula out here. And the Arabian Plate, divided by the Red Sea Spreading Center, the Dead Sea Transform Fault, and the Zagros Collision Zone in the north, where the Arabian Plate has collided with central Iran. And the reason that the Oman ophiolite is so beautifully well preserved, pristine, is the fact that from the Straits of Hormuz syntaxis over to the Indian Ocean is still a remnant bit of oceanic crust in the Gulf of Oman. So this bit of Arabia has not yet collided with the Makran. When it does, it will evolve into a Zagros type orogenic belt. And in turn, Zagros will evolve with 20 million years time into a Himalayan type orogenic belt. So all the dark rocks here are the ophiolite complex, late Cretaceous ophiolite, placed onto the continental margin of Oman during the late Cretaceous. Here is a map. So the Oman mountains are absolutely unique and spectacular. Anywhere in the world, And this was really unknown until a shell research team headed by Ken Glennie and Mike Hughes Clark spent 5 years mapping the mountains, aerial photography and helicopter mapping. And they did the first initial work on the Oman mountains of really great significance. They discovered thrust sheets. The Oman ophiolite they proposed was thrust onto the margin. And it was really an excellent piece of work. And everyone following has basically agreed with the Glennie et al. Tectonic scenario. But of course, now we've got much better precision in terms of pressure temperature work on metamorphic rocks, dating and stratigraphy, fossils, biostratigraphy, etc. So Oman has older orogenic episodes, particularly in the Pan-African and the late Paleozoic, where there was a middle Permian orogeny. But of course, the major one was the Alpine orogeny during the late Cretaceous, when the whole Wilson cycle starts off with the ophiolite emplacement, leading on to continental collision. And because the collision of the two continents has not yet happened in Oman, we have this early phase of orogenesis, ophiolite emplacement, absolutely beautifully exposed. So the ophiolite is this section here in red, upper mantle, gabbroic lower crust, sheeted dikes, pillow lavas, on both sides of a huge anticline. This is one of the world's largest anticlines, a 60-kilometer wavelength anticline of Jebel Akhdar, and the ophiolite is exposed on both sides. So when you unwind all the thrust sheets in Oman, you end up with a paleostratigraphy looking something like this. And this is really the crux of what the Glennie team first discovered, came up with. That all the thrust sheets overlying the shelf carbonates were actually pretty much time equivalent rocks, but of more distal paleogeographic facies as you go from onshore, offshore, and eventually into the ophiolite, which is a Cenomanian, Turanian slice of oceanic crust and mantle. So on the left here, we have the shelf carbonate stratigraphy. This is where all the world's, 2/3 of the world's oil is tied up in various reservoirs up here, notably up here in the Nati Formation. But there's loads of other reservoirs going all the way down to the Permian, the Khuf. The first of the lowermost of the thrust sheets is a shelf slope carbonate facies, which are time equivalent rocks to the autochthonous shelf. And as you go further outboard, you're going into more proximal to distal slope facies of the Tethyan continental margin. And these rocks here are part of the Hawasana complex. This is the Hamrat Duru group, proximal turbiditic sequences coming off the continental margin. And the more distal units out here are the chert sequences, which are starved basin sediments way out in the ocean, dominated by radiolarian chert. And we have these spectacular exotics. These are the Oman exotics, which are isolated seamounts. Most of them are actually Upper Triassic, and they're sitting on a volcanic basement, an alkali volcanic basement, going outboard to the ophiolite itself. So that's what happens if you unwind the whole of the Oman mountains, take it back 96 million years. That's probably looks something like that. So what the Oman mountains are most famous for, of course, is the ophiolite, the Searle ophiolite, which is an absolutely spectacular, incredible sequence of rocks, anything up to 15 to 20 kilometers thick. And there's about almost 10 kilometers of upper mantle, depleted upper mantle, so peridotites, dominantly Harzbergites and Dunites. There's the Moho transition zone. You can actually put your finger on the Moho in several wadi sections in Oman. Leading up to the lower crust, the Moho transition is peridotites and gabbros interlayered, cumulate sequence gabbros, followed by isotropic gabbros, which are probably part of the magma chamber underneath the spreading center, leading up to sheeted dikes, 100% sheeted dikes, meaning 100% oceanic extension above the ridge, and finally pillow lavas at the top, which are absolutely beautifully exposed along the mountains. And most important, of course, along the base, we have the metamorphic sole, composed of an inverted sequence of garnet pyroxene bearing amphibolites and green schists with upside down metamorphism, meaning that heat to generate the metamorphism came from the mantle wedge above. So this is what the Oman Mountains look like. All the woody sections there are absolutely brilliant places to drive. Four-wheel driving is absolutely beautiful in Oman. Almost 100% exposure. We're looking here at mostly mantle rocks, the dark brown Harzbergites of the mantle. And here in a little bit more detail is what the previous slide showed with the stratigraphy of the autochthonous shelf carbonates, which go from the middle Permian, the breakup of Gondwana, the development of a huge Tethyan autochthonous shelf carbonate sequence along the northern margin of Arabia. These are the same rocks that you see all the way along the Arabian Gulf, all the way along the Zagros Mountains, right to the Dolomites, the Alps, and also in the Himalayas the other direction. So this was a spectacular Triassic, Jurassic, and lower Cretaceous sequence of dominantly very stable shelf carbonates. Everything from here rightwards is the lochthon, which are the thrust sheets going from proximal to distal, showing that the rocks deposited in each thrust sheet on top of the other are basically time equivalent rocks. Here's a Google Earth image. So there are three enormous great culminations of the shelf carbonates. One is the Musandam Peninsula in the far north. The central Oman ones are the Jebel Akhdar region here, which is enormous. This ridge of mountains here is 3,000 meters high. And the anticline axis does this spectacular 90-degree bend, plunging down towards the Searle Gap and then coming up here in the Sai Hatat region. And up in the north here near Muscat Asifa, we have a series of high pressure rocks where the continental margin has been attempting to go down the subduction zone. I'll come on to that a little bit later on. And everything dark here is the ophiolite. And you can actually trace the ophiolite on Google Earth images. That is the moho there, dividing the very dark Harzbergites and Dunites of the mantle from the light grey lower crust gabbroic sequence, and down here are more the sheeted dikes and the pillow lavas. Well, this is what the shelf carbonates look like in Jebel Akhdar. And remember, something like half the world's oil and gas reserves are in Eastern Arabia. Saudi Arabia, Kuwait, Iran, Iraq, the Zagros are all in reservoirs that are only really exposed in the Oman Mountains. So these sequences in Oman are extremely well studied, sedimentologically, biostratigraphically. The stratigraphy is extremely well known, and it's possible to match up well drill cores in the foreland to the exposures down here. So this is one of the best wadis in the whole of the Oman, the Wadi Naka, the Grand Canyon of Wadi Naka. There's a village down here for scale. You can see these mud houses. They are two-story mud houses, so this is getting on for 2,000 meters, that cliff section, going all the way from the Jurassic Cretaceous from the Permian, which is deeper down, through the Triassic, the Jurassic, up to the Lower Cretaceous. And the Lower Cretaceous ends with the Nati members here, which is one of the major reservoirs in the interior. So that's what the stratigraphy looks like. This is a view taken from the rim of the Grand Canyon. This is on the other side, the north side of Jebel Akhdar, where again, we're looking at 3,000 meters elevation of the summit here of Jebel Shams, down to about 600, 800 meters down here in Wadi Sakdan. And this sequence shows the entire shelf carbonates from the Permian through the Triassic, Jurassic, Lower Cretaceous up to the Nati formation forms these rocks forming the summit of Jebel Shams. And then the whole thing is folded into this spectacular antiform, the Jebel Akhdar anticline. And in the core of the anticline is the Sake Plateau. And we see here the basal unconformity of the Permian. This is the middle Permian Sake formation lying above the pre-Permian. And the pre-Permian is a whole contortion of rocks from the Proterozoic up to the Ordovician. And there are some spectacular snowball earth deposits exposed right around here, right around the Sake village at the top. And in fact, this hotel you can just see on the rim here. This is the Anantara, which is a beautiful 5-star hotel where we stay for a few nights on our Oman tour. And very pleasant it is too. elevation of 2,800 meters, so it's nice and cool, surrounded by juniper trees and pomegranates and cherry and blossom. In the spring, it's absolutely beautiful. There's a fourth window there called the Hawasana window. So the Jebel Akhdar anticline plunges underneath the Hawasana window. This is another great anticline axis with ophiolite folded all around it. This is a lot more complicated because the shelf carbonates are buried underneath the Hawasana window, and the Hamrat Duru naps are exposed in these three enormous great Helvetic nap type structures. And a lot of them show northeast vergent back thrusting. So the structural geology of the Hawasana window and the subophiolite units is incredibly complicated, but it has been mapped out to an extortionate degree now, so we can actually do balanced and restored cross sections and get a pretty good idea of what it looks like. So these are two of the three big Helvetic naps in the middle of the Hawasana window. This is all in Jurassic, Lower Cretaceous, proximal slope deposits of the Allochthonous Hamrat Duru group. Same units down here, and a bit structurally above these rocks in the Hamrat Duru are these spectacular Oman exotics. These are the late Triassic seamounts. They're a bit like oceanic geos, like you see in the Western Pacific, sitting on top of alkali volcanic rocks, the Habi complex, which are nothing at all geochemically different from the ophiolite completely. The base of the ophiolite is here. This is the banded ultramafics, Hartsbergites and Dunites dominantly. And this is the metamorphic Searle, the spectacular sequence of amphibolites going structurally down section to granulites and eventually into unmetamorphosed sedimentary rocks. And right at the top of the metamorphic Searle, we see garnet and clinopyroxene, as well as hornblende and plagioclase, which makes them granulite facies rocks. And then overlying the Oman exotics is the Searle thrust, and the metamorphic Searle is the Searle thrust, and the base of the ophiolites here. And this is Jebel Misht, which is one of the most spectacular of all of there's hundreds of exotics all over the Oman mountains. They're all structurally right beneath the ophiolite. This one here is 1,000 meters of upper Triassic carbonates sitting on top of alkali volcanic basement at the bottom. And that's the thrust putting Oman exotics over the distal Hawasana chert sequences here within the distance, the Hamrat Duru group. This is Jebel Misht taken from the other direction. This is the most famous rock climbing wall of Arabia. That's 1,000 meters of pretty much vertical limestone. There's about 12 routes up that mountain. And we put a route up here when I was doing my PhD, which was one of the best rock climbs I've ever done. Absolutely spectacular. You get a view from the top, looking over the empty quarter, and it's just beautiful. So to run through the tectonic story of Oman, which is very complicated, but to get some idea, we're going here from the Cenomanian times, about 95, 96 million years old, where the ophiolite was forming outboard in Tethys. This is several hundred kilometers off the continental margin. And this is the reconstruction of the shelf here, going from stable autochthonous shelf carbonates to Hamrat Duru, outboard to the exotics and the Habi volcanics. And then the ophiolite was in place over all these thrust sheets. The Searle thrust has an out of sequence unit, so it actually overlaps everything, even in places to lie on top of the shelf carbonates. And the deeper structural levels here are only seen in a thrust sheet up in the United Arab Emirates in the north, the Bani Hamid thrust sheet, which is composed of granulite facies, carbonates, and quartzites. So that's the only place we see the granulites of the lower crust exhumed up to the surface. That's this thrust sheet here, completely surrounded by peridotite. This is all in Fujairah, one of the emirates in the UAE. So we have granulite facies metamorphics in the deep crust of the north. Around the Muscat area, something completely different. This is the Muscat bit of the ophiolite, which is composed dominantly of the mantle sequence, but you actually get gabbros, sheeted dikes, and even tiny little bits of pillow lava along the coastal section here. But all of these rocks here are in high pressure. This is the same continental margin sequence from the Permian Sake Formation all the way up to the Cretaceous. But down here at the coastal town, little village of Asifa, we've got eclogites. Eclogites are high pressure metabasaltic and metasedimentary rocks that have been to pressures over 21, 23 kilobars, which equates to a depth of about 100 kilometers. So these indicate the eclogites and basaltic sills within the Permian Sake Formation. So those indicate that the continental margin of Oman was actually dragged down the subduction zone at a very late stage, once the ophiolite was already across the margin. And you're going from eclogite facies down here on the coast through blue schists up here. These are metabasaltic blue schist bands, going up to carpholite bearing units, which are about 7-8 kilobars all around the Rui Valley and the base of the Muscat ophiolite. Now this you may think is an artistic impression, but every fold there is real. It's been mapped and it is spectacularly complicated. Everywhere from the left-hand end of that cross section going southwards across Sai-Hatat, you have a completely stable sedimentary shelf carbonate going from pre-Permian basement up through the Permian Mesozoic, and then suddenly up here, as you're going towards the north, all hell breaks loose and you start getting these incredible isoclinal folds. This is the Wadi Mai mega sheath fold, which is the largest sheath fold on the planet in Permian Sake Formation. And this is the eclogite. These are all placed onto one cross section using a long strike balancing techniques. When you unwind that, this is what the sequence looked like. So here is the pre-Permian basement folded during the pre-Permian orogeny. The Ordovician-Amday formation is very thick and it's completely missing in places, and it actually forms the protolith of a lot of the eclogite units to the south. And the ophiolite was already in placing across this, and all of the high pressure units are here. So these are the Permian Sake Formation. The rocks that were to become the eclogites are these little thin black units here, which are basaltic sills and flows and placed into the Sake Formation that was subsequently dragged down to 100 kilometers depth to form these rocks here. This is the Sake Formation limestone, and this is the metabasaltic eclogite of Asifa. So these rocks here were basaltic sills intruded into the Permian carbonates, and they have pressures and temperatures of about 550 to 600 degrees centigrade, 21 to 23 kilobars, and that equates to depths of about 100 kilometers. So this is one of the most spectacular, rarest outcrops anywhere in the world, where you can demonstrate the continental crust has been dragged down a subduction zone beneath an ophiolite during the last stages of the ophiolite abduction process. And this is what they look like from the sea looking back. They are composed of garnet, clinopyroxene, glaucophane, which is a blue amphibole, fengite, epidote metabasites, and there's chloritoid bearing metapelites down there. The pressures here, these are old pressure temperature constraints. We're now up to about 21, 23 kilobars. Permian limestones are the protolith, and we've got a very precise uranium lead zircon ages of 79 million years, which is about 15 million years after the ophiolite formed and started in placing onto the margin. So this is one of our major stops on our geo tour trip, and it is an absolutely spectacular place. It's quite tricky to get to because the mountains are surrounding this beach, but we last 2 years ago when we ran this trip, we got a boat from Sifa back to Muscat, stopped at this beach, swam ashore, looked at the eclogites, and then went on to Muscat. This is what the coast looks like. Here are the eclogites at the bottom. This is the Sifa beach, which is a beautiful beach. You can drive to Sifa village down here, and then you have to clamber around the headland if you want to go there by land or by boat. The sea is absolutely spectacular there. There's coral reefs off Oman, some of the most northerly tropical coral reefs, so swimming and diving here is absolutely brilliant. And the eclogites are some of the most pristine eclogites in any alpine setting at all. Very strange rocks there, but these are the host rocks of the eclogites. Calc schists are probably metamorphosed Permian Sake or Hoof Formation, and the quartz fangite schists are probably metamorphosed Amday, Ordovician Amday Formation. That's far too tricky to get into, just to say that this is the ophiolite, this is the continental margin, and we are dragging the continental margin down. The only way you can do that is by slab pull. So the old oceanic crust that was attached to the continental margin is dragged down the subduction zone, forms eclogite, which acts as an anchor, pulling it down. And then the eclogite, which is far denser, sinks off into the mantle and releases the continental margin carbonate. It's a bit like taking a champagne cork down to the bottom of a swimming pool, letting go of the anchor, and it will just pop straight back up again. And then in the carpholite bearing units between the shelf carbonates proper, unmetamorphosed, and the blue schists and the eclogites are these rocks here. This is Permian Sake Formation carbonate. This is one of the major reservoirs in the interior, the Hoof. But once you get to the mountains in the northeast coast, the folding goes completely crazy. There's a bus here for scale. Everything in red is a thrust fault, a detachment, and everything in yellow is just tracing around the bedding of these folds. So a series of isoclinal folds, hundreds of kilometers of shortening, and a sheath fold is one that's pulled out in the direction of transport. So this is the same Wadi Maya sheath fold. There's a truck bus there for scale. This is the sedimentary bedding, looking straight down the axis of these four sheath folds that are stacked up on top of each other and wrapped around by the Ordovician Amday. So this is Ordovician, this is all Ordovician, this is Permian, and the Ordovician wraps around this. It's like a cigar. We're looking straight south-southwest in the direction of transport. But this is the world's biggest sheath fold by a mile. And I had a master's student, Sam Cornish, working on that, doing photogrammetry, and these are some of the images that we took there by trekking along the rims of the canyon and just mapping out all these incredible fold and thrust structures. Absolutely spectacular. That's an artist impression of these four stacked up sheath fold units here. That's the direction of transport north to south, and the Ordovician wrapping around the top of it. So this is a cross-section across the whole of the eastern part of the mountains, the Sai-Hatat unit here with the thick ophiolites in the Ibra complex, fold thrust of the Hamrat-Duru group over here in the desert. The empty quarter is off to the left, and the south side of Sai-Hatat perfectly well behaves, Permian, Triassic, Jurassic, Cretaceous, and then suddenly here you get all these incredible sheath folding, hundreds of kilometers of crustal shortening, and structurally deeper levels through the blue schists into the eclogites. And then during the lower to middle Maastrichtians, at the uppermost stage of the Cretaceous, it all ended. Ophiolite abduction had ceased, all high pressure metamorphism had finished and was exhumed, and the erosion had truncated it down to sea level. That's this major unconformity here, which marks the end of the ophiolite abduction. Following that, there was about 20 million years of, again, very shallow, very stable, very fossiliferous limestone deposits of the upper Maastrichtian. These are the rudest limestones of the Simsima Formation, overlain by the Paleocene-Eocene Jaffnain. And these are the rocks exposed around Muscat, for example, on some of the folds. So this is a beautiful road cut, typical road cut going through the northern side of the mountains, with the Maastrichtian rudist-bearing limestones here, and these are the fallen basin deposits showing multiple unconformities. So this is a map showing the major anticline axes. So I've showed you some pictures from the Huasna window here of the Helvetic type naps. I've showed you pictures of the south and the north side of Jebel Akhdar, the Sake Plateau up here, the Anantara hotels up here. And then these fold axes suddenly do an abrupt 90-degree bend along the Jebel Nakhl. These mountains here are all about 2,800 meters. And suddenly the anticline axis plunges down to the east, rises up again in Sai-Hatat. And this is the other great big fold axis. These folds are 60, 70, 80 kilometers wavelength. They are enormous. They're bigger than most of the Zagros faults. And then here in the far east in Asifa is where the eclogites are. So all of this unit here is all in high pressure. Only in this area here, as you go into Jebel Akhtar, Jebel Nakhl, these are unmetamorphosed units. So the Searle Gap, this is the main road that connects Muscat to the interior. This is where the pipeline goes that carries all the oil to the terminal near Muscat. And you can actually relate to the pattern of folds and thrust here to a dome and basin interference pattern where you have a biaxial fold interference. This was described initially by John Ramsay in the 1960s. And everywhere you have two anticline axes meet, you have a dome. So you have a dome here, a dome there. And everywhere you have two syncline axes meet, you have a basin. And this is the folded ophiolite basins. So all of these are the basins of the Searle ophiolite here, in Rustak, and in Nizwa down here. So there's a huge debate about what caused the east-west compression. We know what caused the northeast-southwest compression, that's the ophiolite abduction. But what caused this other axis at right angles to it? Some people think it was the collision of India on its way north to make the Himalayas. I don't believe that at all, because when you drive along the Indian Ocean coast of Mazira, the late Cretaceous rocks are flat and undeformed, so it's not seen any collision like that at all. So it's still a bit of a puzzle and lots still to discover. But the top of the unconformity above all the ophiolites is marked by this unit here, the Sim-Simmer formation, which is absolutely an amazing sequence of rocks. They're full of rudists. A lot of these are death assemblage gastropods, big gastropods that big, very, very spectacular. So in this outcrop here, these are the Hawasana cherts, overlain unconformed. The whole ophiolite is missing here. And you've got these spectacular rudist and gastropod death assemblages. This is literally around the corner from Muscat. So this is the part of the Muscat ophiolite, the ultramafic units, the peridotites, overlain by the Paleocene limestones in this case of the coast. So the northeast coast of Oman looks like this, absolutely beautiful little bays, and it's a fantastically scenic area. All of these bays have coral reefs in, so it's very good for snorkeling and diving. Muscat, the capital city, is over here. This is the peridotites of the Muscat bit of the ophiolite, and all of the tertiary stuff here is folded. And they reach up to anything like 2 kilometers thick. The late Cretaceous, the Maastrichtian, Paleocene, Eocene sequence in here, overlying a little window of Harzbergite. This is in one of the wadis in the east. So this sequence here of mountains in eastern Oman, northeastern part of the mountains, goes up to just over 2,000 meters. And these are Eocene limestones on the top with a nice, beautiful box fold dipping off gently towards the Gulf of Oman. And we've had projects looking at the seismic sections offshore from Muscat all the way down to Suwa, trying to trace this geology on land offshore. And then the final jigsaw piece of the puzzle occurs right up in the north of Oman in the Musandam Peninsula, which is the third of the great big shelf carbonate windows. Again, totally different. In the Musandam Peninsula, you have a stacking up of Permian, Triassic, Jurassic, Cretaceous, and thrust sheets of Hawasana and ophiolite repeated. So all of this is a doubling up of the crust. And the reason is because in the far north of Oman is the first indications of the continental collision with central Iran. So everything from here, from the Dibba zone eastwards, is ophiolite and oceanic crust in the hinterland and the Gulf of Oman. But as you go around the eastern seaboard, you have the first effects of the continental collision. So all of this is the late Cretaceous ophiolite and the metamorphic Searle with the Bani Hamid lower crustal granulites here. The Dibba zone, the incredible complicated Hawasana complex, Havey complex between the shelf carbonates. And this is the Hagab thrust, which can be traced on seismic all the way off into the Gulf of Oman, into the Persian Gulf, sorry, to the west, going all the way up to the Iranian collision zone. It's incredibly spectacular. The base of the, this is the Haggard Thrust here in the mountains. We won't be seeing this on our trip because it's up in the UAE. You have to go through the UAE to get to Omani Musandam in the north, but it's part of the whole jigsaw puzzle of how Arabia collided with Iran, and the ophiolite is all preserved in the Oman section to the south. Okay, so what we're going to look at is processes of geology and the geophysics of both the onshore and the offshore. Particular ophiolite abduction processes have been worked out. How you initiate a subduction zone by looking at the metamorphic sole, the granulite and fibrillite metamorphic sole, how you subduct a continental margin to form eclogites and ultra-high pressure metamorphism in the Seafer eclogites, and how you stack up the lower crust underneath the ophiolite in the north, where you're exposing these granulite facies, carbonate and quartzite units, both of which are far too buoyant. You can't subduct them into the mantle. So they go down to something like 10, 8, 9, 10 kilobars maximum, then pop back up again. We're using geophysical seismic images all around the Musandam Peninsula and offshore in the Gulf of Oman to figure out what the ophiolite subsurface looks like. And we're using the same fallen basin images in the Aruma Basin on the foreland to look at the late Cretaceous basin in front of the abducting ophiolite. So here's the Oman ophiolite here, with oceanic crust in the Gulf of Oman, the Musandam Peninsula here, which is the first indications of Arabia, central Iran collision. And this is the Zagros section here, which collided maybe 15 million years ago to create all of these incredible Zagros folds in the Zagros fold belt here. The suture zone runs along here with smashed up ophiolites of the same age of Oman, and the whole thing is offset by strike slip faults in the eastern Iran. So to finish off, just a few pictures of what Oman looks like. It's an incredibly spectacular country. I first went there in 1967 as a schoolboy because my dad worked for Shell and we lived in Muscat. And this is what the capital city looked like, surrounded. It was basically a glorified fishing village with 2 Portuguese forts here, built in the 16th century. This is the Jalali, which was the prison, the only prison in those days, the Sultan's Palace and Fort Jalali, Mirani over here, and this is the whole capital. Wonderful capital city because it can't expand. It's got big spiky mountains all around it. So since the old Sultan Qaboos came to power in 1970, there's been a massive surge of development. He's done an incredibly good job governing the country, and all of the oil wealth has been put into developing the country in terms of schools, hospitals, roads, and tourism. So this is beautiful beaches that we used to go swimming on and going around, snorkeling around here. And there's now 3 hotel complexes on there, which are all very nice. You know, they do developments in a good way. But what is really spectacular about Oman is the old forts. Every village and town has one of these forts. There's watchtowers like this all the way along the Searle Gap. This was taken when I was doing my PhD in Sohar. This is all built up now. But everywhere you go, there are these incredible forts. A lot of them have been restored in a very, very good way. So lots of spectacular tourist stuff to look at as well. And this is an aerial picture taken from an old sky van years ago of what Oman used to look like in the 1960s and 70s. Not a sheet of corrugated iron to be seen. These are all mud brick houses with the old fort and the goat market here, and ophiolite mountains in the background. And the hill villages are also absolutely lovely. This is Bilad Sait up in the Jebel Akhdar, date palms and alfalfa growing there. Aerial photographs of the Jebel Akhdar Massif. This is the one single anticline structure here, dipping down. Nizwa's over here, Rustak's over here. That's about 60-kilometer wavelength fold. Absolutely spectacular. And an aerial photograph looking, these are the suburbs of Muscat, the Rui Valley, and Seafer, the high pressure unit, is over here. So you're going from eclogite to blue schist to carphalite, the big sheath fold down Wadi Maya is down here. And you can, as you can see, it's 100% exposed. It's a geological paradise. the whole of the Oman is just a wonderful place. When we go on our tours, we stay in the Crown Plaza, which is in Kurram. And this is a typical sunset looking across Kurram Beach. At the end of the trip, sit here in the patio with your gin and tonic, watch the sunset, and the mountains of Jebel Nakhl are over here. Absolutely beautiful. So we are running this trip in January 2023 with Indus Experience. And of course, anybody is welcome to come and join us. And I guarantee it will be a 5-star experience in terms of geology, in terms of where we stay. This is Bruce Levell, this is me, and this is Hamid, who is our great driver, contact, friend, tour operator, who runs all the logistics of the 4-wheel drive transport, actually in Oman. And they are a wonderful set of people. They're incredibly hospitable. We did have one day of a spattering of rain, and Hamid just said, "Oh, come to my sister, cousin, uncle, brother's house in Burkat al-Mawz." And we had this wonderful feast that they put on at no notice. They're incredibly nice people. The whole country is spectacular in the extreme, and I just can't recommend it enough. So if you'd like to learn any more about the Oman mountains, here's a nice little hill village, Wadi Tanuf. My book is published a year ago, Geology of the Eastern Oman Mountains, Springer. And this other book here, which describes a lot of my Himalayan geological explorations, has 3 chapters on Oman and the Zagros Mountains at the beginning as well. Another nice little hill village up here, Wadi Tanuf. So that's it. Thank you very much for your time, and I'm very happy to answer any questions if there are any. So over to you, Asiya.
Thank you, Mike. That was amazing. We do have a couple of questions, which I will put to you. Richa Atri, I hope that's the way you pronounce it, Richa. She asks, would you be able to comment on the impact of which of these rocks in absorbing CO2 and the need to preserve those rocks?
Yes, there's a lot of talk about CO2 carbon capture and storage in the peridotites. Of course, half of the Oman Mountains is made of olivine, which is the peridotites of Harzbergite and Dunite. The process is not well known. You would have to drill and frack the ophiolite to an enormous degree. You would have to pump it down there. But one of the natural processes of serpentinization is the reaction of peridotite to water, groundwater. And this locks up CO2 in a mineral called magnesite, which is a white mineral. Quite often you see veins of white cauliflower type minerals everywhere in the ophiolite sequence. And PDO actually had a test case trying to figure out whether this was going to work or not with Peter Kellerman from Woods Hole. And I believe that study is still ongoing. But in effect, it's not going to solve the CO2 problem of the world, because you would have to drill the hell out of the ophiolite, pump it down there. And the main thing is we don't know the rates of the metamorphic reactions. We know the reactions occur. We don't know the rates, whether it takes days, months, 100 years, or whatever. So it's not going to solve the CO2 carbon storage overnight.
Right, interesting. I think while you were talking, you mentioned something exotic. Catherine is wondering, what is exotic?
that was a term coined by Ken Glennie and the Shell team back in the 70s. And they were exotic because they were these mountains of shelf carbonate, dominantly Triassic carbonates, and they're very spectacular. They form 1,000-meter cliffs poking up in the middle of nowhere, very isolated. And when you scrabble around the base of them, they're usually sitting on these Triassic volcanic rocks. So when you reconstruct it, they were the most distal unit of all of the thrust sheets, and they were basically ocean islands. Think of something like Hawaii or the Azores or some island way out in the ocean, sitting on top of a volcanic substrate. And the initiation of the Oman subduction zone occurred right next door to it. One of the theories is that the initiation of the Oman aphiolite subduction zone was because all these exotics were clogging up the subduction zone, because carbonate is very buoyant and you can't subduct that material.
I see. Wonderful. Miranda asks, what sort of distances or times would we be traveling by four-wheel drive?
Well, we haven't done the program exactly yet, but last year, and it will be very similar, going to a few different sites from the one we did in 2019. So we will stay in hotels mostly for 2 nights and then move on to the next hotel. Because the country is so large and we need to cover all the area. But we will be traveling almost entirely by four-wheel drives. That I showed a picture of all the Jeeps lined up, the Toyota Land Cruisers, 3, maximum 4 people to a Land Cruiser, so very comfortable, very roomy. Driving is excellent from the local Omanis, and all of the hotels are 4-star or 5-star. And including 2 nights on the Anantara up on the Sake Plateau, which is the height of luxury.
Great. I'm going to pronounce all of these next few questions wrong, so forgive me. Rafiq Ahmed asks, why such a thick sequence of carbonate rocks are unmetamorphosed?
Metamorphosed.
Yeah, in such a metamorphic orogeny? Is there the geochronology of carbonate rocks available in Oman?
Well, the carbonates are dated using fossils. Fossils are extremely well known, and biostratigraphy is an extremely well constrained science. So all of the Permian, Triassic, Jurassic, Cretaceous shelf carbonates are known dominantly from their microfossil content. You can date metamorphic rocks or igneous rocks. So the ophiolite is dated using uranium lead zircon, uranium lead isotopes on zircons, which is a uranium bearing mineral in a plagio-granite. The plagio-granite is about 1% of the ophiolite. It's the very final fractionate phase. And it's the only way you can date an ophiolite, because there is no uranium, very, very little uranium in the oceanic basalts and almost none in the mantle. So ophiolites are dated using uranium lead isotopes. The stratigraphy of the shelf carbonates and the Hawassa basin sediments are dated using fossils. And we can also date metamorphic rocks in the Searle and the eclogites using uranium, thorium, lead isotopes.
All of these really, really complicated words are exposing me terribly. Philip Nixon has put a statement up there. He says, in 2019, I went on this trip as the most ignorant of geologists and enjoyed it immensely. The people are hospitable, Omani and British. He says, wonderful.
Thank you very much, Philip. Nice to hear you.
That's wonderful. A question from me: at what height is Jabal Akhtar? Is it very, very high above sea level?
Jabal Akhtar, the highest point is Jabal Shams, which is on the ridge of Jabal Akhtar, and that's 3,009 meters above sea level. So the whole ridge drops from 3,000 meters down to about 2,500 meters as you go along the east-west axis of Jabal Akhtar. And then it swings round through Jabal Nakhl, which is a whole series of peaks about 2,500 meters. And they're very spectacular because each one of them has steep sides, flanks, and the ophiolite is sitting down there in the low basins, only at about a few hundred meters or 1,000 meters maximum. So quite often these cliffs going up to Jabal Akhtar are like 2 kilometers high. Right. This one here on the picture I've got on the screen, there's a village there, there's a house there, and these are terraced fields. And this is just the top of the shelf carbonate. Sake Plateau is up on the top. This is in Wadi Tanuf. And these little hill villages cling to the sides of the mountains. I mean, if you've got time, you know, you could spend years trekking around here. I've been up most of the wadis, and views like this are just stunning, absolutely stunning.
I mean, I think obviously because the whole trip is going to be in 4x4s, and you're probably acclimatizing as you're going. So anyone with that kind of issue shouldn't face anything like that.
No, not at all. I mean, you don't even feel at altitude until you're up above 2,500, 3,000 meters. So no, altitude is not a problem.
Fantastic. Miranda again asks, what sort of temperatures would we expect?
Temperatures would be a bit like today in sunny Oxford, anywhere between 20 and 30 degrees. Very rare. You can have spots of rain. January, if it rains at all in Oman, it rains December, January, but they're usually little passing storms, and occasionally the wadis will flood, flash flood. If you get a big storm, they have had cyclones go through Oman, but they're very, very rare. Cyclone Gonu came through in 2005, I believe, and created a huge amount of damage in the Muscat area, but they're very, very rare. Of course, if we do get any rain, we might have to alter the program, because you can't drive up these wadis if there's any indication of flooding going on. But they're easy to get out. There's good roads up all these wadis now, so, and then those four-wheel drives can go anywhere off road. So again, not a problem.
Great. Colin Smith says, non-geologists here have learned a lot of new words tonight. I have to. Were you aware of rudist formations in Ras Al Hamra?
No, because no, there's no rudists at Ras Al Hamra. Ras Al Hamra is where the PDO camp is, and that is all on Paleocene or lower Eocene limestone. So you get beautiful echinoids and gastropods and corals, but not, as far as I'm aware, rudists. I may be wrong. I'm not a paleontologist. If you do, in fact, you don't, because the rudists died out at the end of the Cretaceous. So no, there's no rudists in Ras Al Hamra.
Wonderful. And Brent McGregor is also here. And
Brent.
Again, the geology, the travel, the food, and most importantly, the people were superb, highly recommended. Thank you for that. I believe we don't have any other more questions. If anyone does have a question that comes to you all later on, you're welcome to pop them to me. I will just put my email address here. And if there's anything that pops up, you can do get in touch, and I'll see if we can get those answered for you. And likewise, for any if you wanted to have a look at the program, or you had any questions on the itinerary, again, do feel free to give me a ring or give me pop me an email, and I'll be more than happy to help you out with those. And that is the end of today's talk. Thank you very much, Mike, once again, for sparing your time and going through everything. Thank you for all the participants for joining. And I'm sure Claire will be in touch with the next batch of armchair travels. And oh, there she is.
Hi. Yes, then the next one will be with Last Frontiers, and it will be, let me just double check, because I don't want to get the date wrong for everybody. It will be on, oh, the suspense. It will be on Tuesday, the 5th of July, and this will be on Andean civilization in the human story. So this will be based over in Peru. So hopefully many of you have booked in for that one too.
Fantastic. So thank you once again, and have a good one.
Lovely. Thank you very much, Mike and Asia. See you all soon.
My pleasure.
Bye.
Take care. Bye-bye.